In this chapter, we will discuss about concepts of probability and their applications. This chapter will cover on basics of probability analysis. Then we'll go into Bayes' theorem, followed by various distributions. So let's try to understand what is probability first. In our human life, day-to-day life, we have a lot of uncertainties. There are certain things for which we don't know what's going to happen. To represent what is the probability, what is the likelihood, what is the chance of something happening is called probability. So something happening or something is not happening is represented using a number, which is between 0 and 1. This representation is called as probability. So probability of any event happening or not happening is between 0 to 1. It can take 0, it can take 1, it can be between them. If it is 1, it means it is certain to happen. If it is 0, means it is certain not happening. And sum of all possible outcomes, probabilities of all possible outcomes will be equal to 1. For example, if I toss a coin, I can have head and tail. Only these two can happen. These are the possible outcomes. If I sum the probability of getting head as well as the probability of getting tail, it should be 1. How to calculate probability? It is done using what is called as an objective approach or relative frequency approach. Probability of any event is equal to number of times, number of occurrences of the event by how many trials you have done or how many outcomes you have. For example, probability of getting a head when you toss a coin is 1 by 2. Why? You have one head and there are two possible outcomes, head and tail. So 1 by 2. If you say, what is the probability of getting a spade in a 52 card deck game? 13 spades are available inside the deck. 52 is the total number of cards you have, so it is 13 by 52. Here is an example from a company where they are selling some paints. They have white latex paints which are sold at 0, 1, 2, 3, 4 gallons per day. And they have observed how many gallons have been sold in the past 200 days. In the past 200 days, 40 days there was no gallon sold on a single day. 80 days there were 1 gallon per sold. 1 gallon of paint sold. For 50 days there were 2 gallons, okay, and so on and so forth. So they represent them in the table here. So 0 gallon demand for 40 days, 1 gallon for 80 days and so on. If you sum up the number of days, you will get the total number of days, which is 200. Now, if you want to find the probability of selling 0 gallon per day or demand being 0 gallon per day, 40 by the total number, which is 200, you get 0.20 and so on and so forth. The sum of all these probabilities should be equal to 1. So you can see individual probabilities are between 0 and 1 and the sum of all probabilities, because we have mentioned all the possible outcomes, and the sum of all this should be equal to 1. And there's another way of calculating or finding the probability. Let's say we don't have any past history or we don't have some of these records to find out these values. Then we can determine the probability of any event using some opinion polls, getting information from experts or some other methods like. In the case of events, there are two important things we need to understand. One is called mutually exclusive. Mutually exclusive meaning if one event occurs, the other one cannot occur. Only one of the events can occur at any time. Example, if I toss a coin, I can either get a head or a tail, but not both. Okay, only one of them. This is called mutually exclusive event. If you roll a die, you can get 1, 2, 3, 4, 5, 6. It's a 6-sided die. Only one of them can appear. This is called mutually exclusive. Next one is called collectively exhaustive. Collectively exhaustive events meaning you are able to list all the outcomes, all the possible outcomes for the event. For example, if you take tossing of a coin, you have head or tail. These are two possible outcomes. If you roll a 6-sided die, you have only 6 possible outcomes. 1, 2, 3, 4, 5, 6. For this is called collectively exhaustive events. So here for each of those 1, 2, 3, 4, 5, 6, when you roll a 6-sided die, they have mentioned the probability here, which is 1 by 6 each. If you sum them up, you get 1. If you want to represent mutually exclusive and not mutually exclusive events in Venn diagram, it should be like this. A and B are events, they are mutually exclusive, so there is no overlap between them. Here A and B are events, they are not mutually exclusive, there is some overlap. Or there's a possibility that you are in this region where you have both A and B appearing at the same time. Here is an example given. You have a deck of 52 playing cards and you want to do two events now. Event number 1, which is A, event A, you want to draw a card with number 7. Event number B, you want to draw a card which has the heart symbol inside. So there are 4 7s inside the deck of 52. 4 cards which contain 7. So its probability of getting A, which is 7 is drawn, is 4 by 52, which is equal to 1 by 13. Heart, there are 13 heart cards inside the deck of 52. So its probability of heart is drawn is 13 by 52. Are these events mutually exclusive? This is the first question. Drawing a 7, drawing a heart. You can draw a card which contains number 7 as well as the heart symbol inside. That means these two events are not mutually exclusive. Are these the collective exhaustive events? Are there no other thing that can happen? You can have number 1, number 2, number 3 and so on. You can have spade and other things instead of heart. So they are not collectively exhaustive events either. So you have what is called intersection of events. Intersection meaning two things can happen. A and B. A intersection B. This is represented by probability of A intersection B or A and B or AB, which is called as joint probability. Union, it's like A or B. Any one can happen. Okay? Probability of A or B, which is A union B. In the previous example, let's talk about intersection of events. If you say A is number 7, B is hearts. So A and B means you should have a card which has hearts with 7. Both should be there. And. So you have only one card which is like this. So it is 1 by 52. If you talk about union of A and B, you can get a card which is of number 7. Also you can get a card which is of heart. So you have a heart with number 1, heart with number 2, or 7 with spade, and so on and so forth. Any one of them. In this situation, the number of cards you can get is 16 by 52. That's a probability. How to calculate this? We will discuss now. If you want to calculate union of two events, then we use a rule called additive rule. And if your events are not mutually exclusive, if there is a overlap, okay, then you say probability of A or B equal to probability of A plus B minus probability of A plus B. A and B. Okay, you need to have this minus, the subtraction here. If the events are not mutually exclusive. If the events are mutually exclusive, you only say probability of A plus probability of B. Right? So here you can see probability of A or B equal to probability of A plus B minus probability of A and B. So you get all these values, you get 16 bar 52. You might wonder why we need to put minus probability of A and B. Let's go to the Venn diagram, which will give us an answer why we need to do that. If they are not mutually exclusive, probability of A contains this part, probability of B also contains this part. So if you are going to sum them up, probability of A plus B, this intersection part is added twice, not once. So we want to subtract it. Okay, you just subtract it like P of A and B. That's it. So it's clear now from these definitions here. Conditional probability. What do you mean by conditional probability? If an event has already happened and then we are expecting some other event to happen, that is called conditional probability. Probability of A bar B. B has happened, we are expecting A to happen. This is represented using probability of AB by probability of B. So probability of AB equal to probability of A bar B into probability of B. Like for example, if you are talking about given a heart has happened, you have taken a card, it has heart symbol inside, and we want to see whether there is 7 there. Okay, so A is getting 7, B is heart. So heart, this is already done. A is what? B is already done. A is what we are looking for. Probability of AB by probability of B. So this is 1 by 52 by 13 by 52. The probability of having 7, getting 7 when you have already drawn a heart card is 1 by 13. And we can also study about dependent event, independent event. There is a relationship between the education and the income level, generally. Right? So this is called dependent. If you talk about getting a hearts card, getting a clubs card, they are independent events. So things like this can also be discussed. If let's say you want to find out the conditional probability of an independent event, probability of B has happened, we want to see probability of A. Probability of A and B are independent. There is no relevancy between them. In that scenario, you will say probability of A bar B equal to probability of A. Okay? Probability of A and B equal to probability of A into probability of B. For example, if let's say you want to toss a coin twice, the first time you get head, the second time you get head. Is there a relevancy between first time you get head means second time you should get head? There is no relevancy. So they are independent events. Probability of A, which is getting ahead, is 0.5 first time. Second time is also 0.5. If you want to find probability of A, B, two events now in succession, we just multiply them. 0.5 into 0.5, which is 0.25. Here you are given a situation where you have a box which contains 3 black balls, 7 green balls. So total number of balls is 10 now. 3 plus 7, 10. Probability of getting a black ball in the first draw is 0.3. This is 3 by 10. Okay. This is called marginal probability. If you want to draw 2 green balls from the box, first time you withdraw a green ball which is 0.7. Second time you withdraw it is 0.7 because it is 7 by 10. And you multiply them, you get 0.49. This is called joint probability. Here you need to take into consideration one important point. The important point is you are going to replace the ball. You take a ball, you put it again. Then you withdraw the second ball. If let's say we don't replace it, that means if you take the first green ball, the number of green balls in the bucket becomes 6 already. And the total number of balls inside the bucket will become 9. Okay? So this will be like 6 by 9 if you don't replace it. The second probability of getting the green ball in the second draw. But because we are replacing it, here it is same. The probability does not change. Then if you are talking about probability of withdrawing a black ball on the second draw when you have already withdrawn a green ball in the first draw. Withdrawing a green ball has no impact on the black ball. So it should be equal to probability of black ball. Okay? It's not a conditional probability now. It's just a marginal probability because they are independent events. And if you are talking about taking a green ball, okay, and second time you are getting the same green ball, because you are putting the ball back in, then it is same. It does not change. Okay? It's again no impact. First time you get a green ball, second time you get a green ball, no impact by the first time on the second time. Because you are going to replace the first ball inside. So it is just P of G. Another example, you have a box in which you have 10 balls and there are 4 balls which are white and lettered, 2 balls white and numbered, 3 balls yellow and lettered, 1 ball yellow and numbered. So we are just representing WL, which is white lettered is 4 by 10 and so on. If you want to see number of white balls, just add the number of white, 4 plus 2, which is 6. Yellow ball is 3 plus 1, which is 4, so 4 by 10. Yellow with lettered, 3 by 10. Yellow with numbered is 1 by 10. And lettered, you just add the lettered ones, 4 plus 3, which is 7 by 10. Numbered, which is 2 plus 1, which is 3 by 10. Okay, you get all these values. And if you want to put some conditional probability. Conditional probability that the ball drawn is lettered given that it is yellow. So if you want to say yellow is what you have taken and you want to see whether the ball is lettered or not, then you have to use probability of YL, which is yellow as well as lettered, by probability of Y, which is the yellow. You get the values here. And if you want to verify it back, you just multiply probability of L bar Y into probability of Y. You should get the probability of YL or Y and L. Next, we are going to study about what is called as Bayes theorem. Bayes theorem, here what we do is you have some prior probabilities, some known probabilities. You get some extra information. Using the Bayes process, you calculate, you find out what is called posterior probability. These probabilities are used to replace the prior probability or is used to go for the next step. Here is an example. You have a cup in which you have 2 dice. You're going to throw the die, right? And you will pick one die and throw. And among these 2 dice, one of them is biased, which is loaded die. The other one is unbiased die. So probability of getting a number 3 on a fair die, which is an unbiased die, is 1 by 6, which is 0.166. Probability of getting number 3 on a loaded die is 0.6. And you got to choose one of them from the cup. Okay, so probability of getting a fair die to throw is 1 by 2. Probability of getting a loaded die is 1 by 2, 0.5 each. Right, so now we are going to check what is the probability that the die you have rolled is a fair die. Or you are going to check what is the probability that the die you have rolled is a loaded die. So fair is, taking a fair die is 0.5 because you are just taking at random. Taking a loaded die is 0.5 also. There are only 2 dice. And if you want to get 3 from a fair die, it is 0.16, it's already given. 3 from a loaded die, which is 0.6. Okay, it's already given also. So loaded is taken, you are getting 3. Fair is taken, you are getting number 3. Right. Now we want to find out probability of 3 and fair. It's easy to find, you just have to multiply 3 bar fair into fair. Similar, 3 into bar loaded into loaded will give you 3 and loaded. So you get these two values. Now if you want to find out probability of getting 3, just add these two. Okay, this one plus this one, 0.083 plus 0.3, you get 0.383. This is the probability of getting number 3. Now you want to do the reverse. Probability that you have number 3 and you want to see whether the die you have got is a fair one or not. Okay, given number 3, you want to check for fair die. So again, fair and 3 by probability of 3. So probability of 3 we have just calculated. Probability of 3 and fair also we have calculated. So it's easy now to calculate these values. So you just get the value. Similarly, you can do for, you have got number 3, you are going to check whether the die is loaded or not. Okay, if it is loaded, what's the probability? So these are called as revised or posterior probabilities. Okay, you can use this to revise our prior probability. So here is just the tabular format of what you have done before. Probability state of nature is A, which is P of B bar A into P of A is equal to P of B and A. And there is also representation called A dash. A dash means opposite. A is head, A dash means tail, like this. A is fair die, A dash is loaded die. Probability of B and A by probability of B is equal to probability of A bar B. We know these things. So you just put their values, you get the answer. In the Bayes theorem, here is a equation given. Probability of A bar B equal to probability of B bar A into probability of A by probability of B bar A into probability of A plus probability of B bar A dash into probability of A dash. So A dash is the complement of A. If A is a fair die, A dash is a loaded die. Okay, and you know what is conditional probability. So if you want to find like this using the Bayes theorem, probability of getting a fair die provided you have number 3 being rolled, you just say this is A bar B, that means B bar A, which is 3 bar fair into fair. Same, 3 bar fair into fair plus 3 bar loaded because it is A dash and A dash here, which is loaded. You get all the values, you get 0.22. And if you want to go for the next experiment, you have rolled the die one time, you want to roll it again. You want to get 3 again. Okay. So you know already fair die, you know loaded die, getting a fair die is 0.5, getting a loaded die is 0.5 also. If you want to calculate, you are taking a fair die, you are playing it 2 times, throwing it 2 times, rolling it 2 times. Both the time you get 3. So probability of getting 3 when you have a fair die is 0.166. So multiply it 2 times, you get this value. Similar 3, 3 with a loaded die, you get 0.36. If you want to find probability of 3, 3 and fairness, so 3, 3 bar fair into probability of fairness, you just multiply them. Similar 3, 3 and loaded. And if you want to find fair bar 3, 3, now the opposite, the reverse, probability of 3, 3 and fair divided by probability of 3, 3. Okay, so use the 3, 3 value. How do you get probability of 3, 3? You just have to get the values here. Okay, and you just get the final result here. So here you can see after the first roll of the die, the probability of that the die is fair is 0.22 and the die is loaded is 0.78, but after the second roll you see the probability has changed. Okay, for the fair die it is 0.6067, for the loaded die is 0.933. This ends that topic. Now we will discuss about what is called random variable. Random variable is nothing but assigning a real number to every possible outcome in an experiment. For example, if you have number of mobile phones sold in a day, okay, you have number. And these random variables can be discrete, can be continuous. Can be discrete means it has finite elements, number of elements or limited set of values. Continuous, you have a range and it can take any value within the range. There is a lower value, upper value. Okay. For example, if you are talking about you are going to inspect some items, you have 600 items to be inspected. So the number of items you can inspect is between 0 to 600. So it is a limited, it's a fixed list, it is the discrete random variable. And you are going to sell something, right, or you are going to respond to some letters, for example, and there are 5,000, so there's a range. If you are talking about building an apartment, how many percentage is complete? Between 0 to 100 can be any percentage, it can be 1.5, 2.3, 3.8 or whatever, 25, 65, whatsoever. So this is a range. Similarly, you can get ranges or which is called continuous random variable. And if you have like student responding to a questionnaire, and you have like strongly agree is 5, agree is 4 and so on, you represent them with some numbers, then again it's a finite list of numbers, so it is discrete random variable. A machine is defective means it is 0. If it is not defective means 1. Again, it is a finite list of numbers. So this is a discrete random variable here. So let's talk about a discrete random variable. You have to assign some values. Okay. You have a class of algebra students. There are 100 students there. You have a quiz, and the quiz has some questions, and there are scores like this. Lowest score is 1, highest score is 5. Okay. So here we need to follow certain rules here. Evens are collectively exclusive and mutually exhaustive. Okay, you have all the list available. Individual probability values will be between 0 and 1, and the sum of probability should be 1, which we know already. So here you can see, if somebody gets 1, he is not going to get 2. Somebody gets 3, he is not going to get any other number. So it is mutually exclusive. And the collectively exhaustive, because the values will be from 1 to 5. There's nothing else. There's no 6, there's no 0, nothing else. So number of people among 100 students is represented. This is using the relative frequency approach. 10 by 100, 20 by 100, 30 by 100, and so on. So you get the probability of each individual. And here it is drawn here. Okay. So this is the class distribution of the class, right? So for 1, probability of 1, probability of 2, probability of 3, 4, and 5. And here we need to understand the central tendency of the distribution. So to be the middle is called as a mean or expected value. But the amount by which there is difference between one value to another is called variability, which is named as variance. So how to calculate the expected value, which is the central tendency, is using this equation here, or formula here. Xi into P of xi, summation. Take all the random variables, multiply them with the probability of each random variable, and sum them up. Okay, so this is how you do it. So if you take the previous example, 5 into 0.1, 4 into 0.2, 3 into so on, so each probability is multiplied with the respective values, and you get the sum, the expected value or the central tendency. Next, if you want to calculate the variance, what is variance? Variance will tell you how much is the distribution like. How is the dispersion? Is it close? It is very far? Is it dispersed nicely? Whatsoever. So here, if the value of a variance is low, it means outcome is very close to the expected value or to the mean. If it is high, it is spread out. It is far away from the central tendency. So this is the rho square, which is equal to variance. You have sigma x minus ex square p of xi. Okay. So get each p of xi, which is the probability. X minus ex is the expected value. And you square them up, you multiply it with the probability. Again, you can do it. 5 minus 2.9 is the mean value. You got it from the previous one. E of x square into 0.1 plus 4 minus and so on. For each one, you have to calculate. Standard deviation is the square root of variance. So you take variance, you just square root. Okay, you get the variance. So here is the answer for the current example. You can solve them using Excel or any other tool that is given to you. The above one, it's possible if you use what is called as discrete random variable, because you have to use xi, each xi, 1, 2, 3, 4, 5. If let's say you have continuous random variable, it's not possible. You cannot take all the values because there are too many values to be considered. So in the case of continuous random variable, sum of all the variables, all the probabilities should be equal to 1. This we know. There is one extra important point to understand. Probability of each individual value. If you take a small value, 2.5, and you want to find the probability of 2.5, that is 0. Okay? Individual value will be 0. Sum of all the probability values will be equal to 1. The probability distribution defined by a continuous mathematical function is called probability density function, or it also called as probability function, probability density function. And if you want to represent it for the discrete random variable, we call probability mass function. In discrete, it's called probability mass function. In continuous, it's called probability density function. How to calculate the probability density function? Simply, we calculate the area under the range of interest. We just have to calculate the area. Okay? And you have to understand, adding any single point will not increase or decrease the value. For example, if I say from 5.22 to 5.26, if I include 5.26 like this, less than or equal to, this will not change because probability of an individual value will be 0. Okay, it is 0. Similar, if I add 5.22 alone, or if I add both of them, so probability of 5.22 less than x less than 5.26 is equal to 5.22 less than x less than or equal to 5.26. Adding any one point or not adding that point will not make any difference here. Why? Because if you want to calculate the area for a single point, it will be nothing. Okay, a single point. You cannot get any other value there. You won't have the width to calculate things like. So it will become 0. Now we are going to discuss about distributions. First we will discuss about what is called binomial distribution. It is a discrete distribution. Many a times it is applied for business experiments using the name of Bernoulli process. So Bernoulli process is described like this, okay? Described using the binomial probability distribution. Each trial will only have 2 possible outcomes because it is binomial. There are only 2 possible outcomes. The probability of each outcome stays the same. For example, if I get probability of head now is 0.5. If I do a trial after 10 minutes, probability of head should be 0.5. Cannot change. Okay? For every trial, the probability of getting an outcome should be the same. The trials are statistically independent. They are independent of one another. There is no dependency between the first trial and the second trial. The number of trials is a positive number, which we all know. So in the case of binomial distribution, what we are trying to find? We are trying to find this. We are trying to find, okay, probability of a specific number of successes in n trial. Let's say I have 10 trials. Can I have 5 success or not? 5 times I want to have head in 10 trials. Okay. So number of trials is n, and probability of success is p of a single trial on any single trial. So r is the number of success. Q is 1 minus p. Obviously failure is 1 minus the success. And this is calculated. Probability of getting r success in n trial is n factorial by r factorial into n minus r factorial into p power r and q power n minus r. Okay, and factorial you know already how to calculate factorial. N factorial is equal to n into n minus 1 into n minus 2 until 1. 1 factorial is 1, which we all know. Right, here is an example given. If you want to get 4 heads in 5 trials, 5 times I am tossing a coin, I want to see 4 heads. So R number of success is, in my definition, the success means heads, getting heads. So R equal to 4, number of trials n is equal to 5, probability of getting a head in a single trial is 0.5, probability of not getting a head is 1 minus 0.5, which is 0.5 also. So you just apply it in the equation and you get the value here. 4 success in 5 trials. And if you want to calculate for 0 success or 1 success, 2 success, you can apply in the equation and get the value. And this is the representation. Here is a company where they are going to manufacture some transistors. Every hour they have a random sample of 5 transistors taken, and they want to see whether the probability of having 1 transistor is defective, it's not in good shape, is 0.15. What's the probability that 3 or 4 or 5 of them are defective? So simply n equal to 0.5, and defective is what I'm looking at. So considering defective as like a success now, to find a defective is a success. So P equal to 0.15. R equal to 3, 4, 5, because I'm looking for 3, 4 and 5. So you get all the 3 values, you just sum them up. Probability of A or B equal to probability of A plus probability of B, like this. So here you can see it's, you don't do any minus or anything here. So here you just sum them up. So you take the probability for 3, 4 and 5, you just add them, you get the values, okay, 3 or more. And in the case of binomial distribution, you have expected value, which is the mean, is n into p, number of trials into probability of success in a single trial. Variance is np into 1 minus p. You just apply them in the equation, you get answers. You can also solve them using some mathematical Excel functions like binom.dist. There is a function, you can apply to it. Normal distribution. This distribution, this is a second type of distribution. Here it is a continuous probability distribution, it's very popular. The probability density function is given by this equation, where you have the standard deviation, you have the mean is given, mu is given, the rho is given, all these are given, okay. You can calculate them. So here in the case of normal distribution, you can change the mean, but if you maintain the same standard deviation, the curve will not change. Curve will remain the same, but it will shift left or right to the lower direction, upper direction. But if you reduce the standard deviation, if it becomes smaller, the curve will become narrow, okay? Or if you use a larger standard deviation, it will become flattened. It will flatten for a large region. So actually it is represented in the case of normal distribution, the mean in the middle, the curve is symmetric to the mean. From the mean it is symmetric. If you shift the curve, mean, it does not change the shape. It will remain as it is. It will just go left and right, okay? Which you have just now discussed here. So you can see value on the x-axis is measured in the number of standard deviation away from the mean. How far you are from the mean. That is what is calculated here. So when you are given a normal distribution, we want to convert it into what is called standard normal distribution. What do you mean by standard normal distribution? Standard normal distribution, the mean is considered to be 0, standard deviation is considered as 1. Okay, so how to calculate? You can calculate z, which is the standard random variable, is equal to x minus mu by the standard deviation. Okay, you can calculate this. So z will tell you how many standard deviations from x you are. 1 standard deviation, 2, 3, 4, wherever you are. And x is a random variable we want to measure. For example, if you are given the mean as 100, standard deviation is 50, you are asked to find the probability that x is less than 130. So x is 130 minus 100 by 50. You get like 2. Z is 2. So z is 2 standard deviation. So you can simply mark it in the picture here. So you can see mu is 100. So if z is 2 and the standard deviation is 15, so this is the first one, number 1. This is number 2, 15. 100 to 115 is 1. 115 to 130 is 2. And here you asked find x less than 130. So it's less than here. So if you want to calculate, you have to use the standard table and you find the value. Okay, standard table goes from left to right. So look for the value, look at the table. The table gives you in the first column you will find z, and the decimal points are also given. So it is 2.0. So you have to find z is 2. So this is the value 0.97725. Right? So this is less than. If you want to find probability of x greater than 130, you just have to subtract 1 minus this. Because remember, in the case of normal distribution, we start from left here, from the left to the right. If I want to find this, I get the whole distribution is 1 minus this part here. Okay, minus the shaded part here. The remaining is not shaded or unshaded part. You get the value. So probability of z less than minus 2 equal to probability of z greater than 2. So they are just one opposite to each other. Here is the same situation where the mu is given, which is the mean is 100, standard deviation is 20. They want to complete the job in 125 days. How to do it? Okay, and there is a condition: if you complete later, then you have to pay some fine, right? So here it is, things are given. So you have to calculate z equal to x minus mu by sigma, which is 125 minus 100 by 20. So standard deviation is given. So 25 by 20, which is 1.25. Go to the value in the table, you get 0.84 something. So the probability that you will not violate the contract, you will finish within 125 days is 0.89, which is like 89%. And if they change the equation, you want to finish it in 75 days, it is minus 1.25. Remember, minus 1.25 is symmetric to 1.25, as you know. You just have to calculate 1 minus the previous value. So 1 minus 0.89, you get 0.105, whatever. It's approximately 11% you have a chance that you will finish in 75 days. Okay. And if you want to calculate from 100 to 125, then you have to calculate for 125 less than or equal to 125 minus probability of x less than 100. You just have to 110. You just get, you know already for 125, you have to calculate for 110. You just have to subtract the values and you get the answer like. So just subtract between those values, you get the probability. So this is the standard normal distribution table. Part of the table is given to you here. You can also calculate them using Excel and whatsoever, using norm_dist function, which is available in Excel. Next, we are going to discuss about what is called an empirical rule. Normal distribution can provide some precise probability, but sometimes we don't care about precision. We just want to make it quickly. Okay. So here is a representation given. If your value is plus or minus 1 into standard deviation, then the value is like approximately 68%. If it is within plus or minus 2, it is 95. If it is between plus or minus 3 standard deviation, it is 99.7%. So you can see here, if you want to calculate for less than 75, mean is 100, standard deviation is 20. So you can calculate A equal to 100 minus W into 20, and you calculate W here, which is this value. Right? So it is 1.25. 1.25 mean it is between 1 and 2. Okay? So it's like 1 and 2. And you can calculate it's between 16 and 2.5%. Okay? So it's between 2.5 and 16. Why 16 and 2.5? Remember, if it is more than 1, okay, less than or equal to plus or minus 1, then it is 68%. If it is more than, it is 16%. And then more than 2 is 2.5. So it will be between. It's between 2 and 1. Okay, from the standard deviation. Similar, if you want to calculate for 80, for example, then you get a value of minus 1 here. You can use the previous equations to calculate. Z equal to minus 1, and if you want to subtract, you get 15.86 plus or minus 1, which is 1, you get the value as 16%. So you can calculate easily by saying 16%. If you use actual value process, you get 15.86. They are close values. So this is where you are not worried about precision, but you want to get the value quickly. And we have what is called F distribution. It is used with regression models. It is a continuous probability distribution. Actually, F statistic is a ratio of two sample variance. You have two sets of degree of freedom, one for the numerator, one for the denominator. Okay, the degree of freedom is based on the sample size, and it is one for the numerator, one for the denominator. And if the probability of large values of F are very small, okay, if you have a big value of F, then the probability is very small. So how to calculate? Here's an example. df1 equal to 5, df2 equal to 6. Probability is also given, which is alpha is 0.05. You use the given table, F distribution table, you get the values. Okay, this means F greater than 4.35 is equal to 0.05. So the probability is only this value if F is greater than 4.39. So you can see here, if you are above 4.39, then the value is, the probability is a small value. You can also calculate these things using Excel. Next, negative exponential distribution. This is also a continuous distribution function. It is used mostly in queuing models or queuing theory. F of x is equal to mu e power minus mu x. X, capital X is a random variable here. Average number of units the service facility can handle, which is mu, mean again. E is the natural logarithms, okay, which is 2.718. Here, if you want to know what is the expected value, which is 1 by mu, and the variance is 1 by mu square. So you can see here the probability that an exponential distribution time required to serve a customer is less than or equal to time t is given by the formula. If you have like a specific time, I want to finish this in 5 minutes, 2 minutes, or if you want to see the data will go from one place to another in 2 seconds, you can calculate using this equation, 1 minus e power minus mu t. Here is an example, a company which can install some things, which is working on some automobiles and trucks. It can install 3 new mufflers per hour. Service time is exponentially distributed. So x is the exponential distributed service time. Mu is given 3 per hour. T, which is half an hour, 1 by 2. Okay. So you are going to calculate what is the probability that the time to install a new muffler is 1 hour less than half an hour or less. Okay, half an hour or less. So you can calculate P of x is less than or equal to 0.5. 1 minus e power minus 3 into 0.5. You get the values. So you can see here, if you want to finish it within half an hour, this is the value. Half an hour is represented as 0.5 here. And similarly, if you want to calculate for 1 by 3, 2 by 3, you want to calculate for different values, you can get all the answers here. You can calculate these things using Excel representation also, Excel also. Next one is called Poisson distribution. This is a discrete probability distribution. It's again used in queuing models, but it is used to calculate arrival rates, not the time, not to say what's the probability to finish within a specified time. Here we are going to calculate arrival rate, how many packets will arrive over a specified time. Okay, so number of packets. So P of x is equal to this here you are calculating the average value, power x e power minus the average value by x factorial. Okay, x is the number of occurrences and number of arrivals or number of occurrences, and the average, which is the lambda value. You have the lambda value, e power minus lambda. Here, like how many patients come to a clinic, how many come to a airport, how many packets come in, and so on and so forth. Remember, the Poisson distribution and exponential distribution are related to one another. The number of occurrences, if the number of occurrences per time period follows a Poisson distribution, then the time between the occurrences, between the each coming, follows an exponential distribution. For example, the number of phone calls arriving at as a customer center follows a Poisson distribution. For example, the mean is 10 calls per hour, then the time between each call would be exponentially distributed, which is 1 by 10, okay, which is 6 minutes. 60 minutes is 1 hour, right? Within an hour, you have 10 calls, 6 minutes. So in the case of Poisson distribution, it is unique by the concept of exponential expected value and the variance are the same. They are both lambda, okay? So you can calculate probability of getting 0, 1, 2, 3. You have to use the appendix to get the values for E, okay? exponential. So you can represent them for different values here. You can also represent them in Excel. So this completes this chapter.